Hello, grade 7 students. This is Mr. Dudstick Daw, your new mathematics teacher in grade 7 for this academic year 2020-2021. And the first topic that we are going to discuss is about set. A set is a well-defined collection of distinct objects. When we say well-defined, the group of objects inside the in that set should be describable. When we say describable, you can give descriptions on the objects on that set. And also, it should be measurable. No? The group of things or objects in that set should be measurable. When we say measurable, let's say the set of handsome students, it is not measurable because we uh, what is handsome to me might not be handsome to other people, no? So it is not measurable. And the group of things should be distinct. When we say distinct, there is no repetition of objects. And each object should be unique. So that is the definition of a set. A set is a well-defined collection of distinct objects. These are examples of a set. Set A is a set of DLA grade 7 students. So these are the possible elements of set A. Second example, set B is a set of DLA grade 7 teachers. These are the elements of set B. Set C is the set of vowels in the English alphabet. And these are the elements of set C. Elements are the objects in a set. For example, set D is a set of whole numbers less than 10. So what are the possible elements of set D? When we say whole number, we will start with 0. No? 0, 1, 2, 3, 4, and so on and so forth. So the possible elements of set D are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Notice that we didn't include 10 because the restriction should be whole number less than 10. And 10 is not less than 10. 10 is equal to 10. So we exclude 10. Another term for this lesson is the cardinality of a set. It is the number of elements in a given set. So to find the cardinality of a set, just count the number of elements. So for this example, set D, there are 10 elements. And the cardinality of set D is 10. No? Because there are 10 elements of set D. Since we can count the number of elements of set D therefore is a finite set. So a set is finite if we can count the number of elements or if we can determine the cardinal number of that set. Uh, Otherwise, it is infinite. So elements are the objects in a set. Another example, set is a set of negative integers. So what are the possible elements of set E? So set E, the possible elements are, there is no first element because we cannot identify the first element because uh, there is no restriction on this set. So all negative integers. So we cannot identify all. No. Instead, we will use ellipsis. This ellipsis means uh, continuously. No, will continuously. So dot dot dot. Then -3, -2, -1. That means before -3, there are infinite number of negative integers before -3. So the cardinality of set E is, we cannot count the number of elements. So set E is an example of an infinite set because we cannot determine exactly the cardinality of set. Another example, the set F is a counting of numbers less than 10. So when we say counting numbers, we will start with 1. 1, 2, 3. Unlike sa whole number, we will start with 0. Okay? So let's identify the number of elements of set F, starting with 1, 2, up to 9. So how many elements are there in set F? So the cardinality of set F is 9. Why 9? Because there are 9 elements of set F. Set D is a set of vowels in the English alphabet. So what are the possible elements of set D? So what do you think is the cardinality of set D? Yes, you're right. The cardinality of set D is 5. So since we can determine the cardinality of set D, therefore set D is an example of finite set. There are two ways to denote or describe a set. The rooster method, the elements are listed and separated by commas. And the example of this is this one, set D. The elements are A, E, I, O, U. Another way is the set builder form. In set builder form, the elements are described using X such that X is, and so on and so forth. When you read this, set D is the set of X such that X is a vowel in the English alphabet. So, uh, when you write the set builder form from rooster method, always use singular, no? Always singular in form. Although there are 5 elements, E, I, O, U, always singular because you are just describing the elements. So, set D is a set of X such that X is a vowel in the English alphabet. And X here is a variable. That means we can replace any of these 5 vowels to X. Another example, set E, the elements are 2, 3, 5, 7, and 11. So in set builder form, set is a set of x such that x is a prime number less than 12. So 2, 3, 5, 7, and 11. All these are prime numbers. Another example, set F, the elements are negative 15, negative 13, negative 11, negative 9, and negative 7. So how can we translate this to set builder form? Set F is a set of x such that x is a negative odd integer between negative 16 and negative 6. Another one is set F is a set of x such that x is a negative odd integer between negative 17 and negative 5. Next is the null or empty set, a set that contains no element. This is the symbol for this. Okay, so a brace or this one. So this is the symbol for empty or null set. So example, set F is a set of negative integers greater than negative 1. So there is no integer greater than negative 1. So negative 1 is the largest negative integer. So when we rewrite this set to roster form, ganito yon. Set F is equal to empty set or null set. So that's all for today. Thank you very much for attending my class. See you on our consultation day. Bye.